Hello everyone, today we are going to solve LeetCode problem number 1888, minimum number of flips to make binary string alternative. This is the question. So in this question, we'll be given a binary string, and on the string, we can do two type of operation. Type 1 operation, we can remove the character at the start of the string and append that same character to the end of the string. And type 2 operation is pick any character in the string and flip its value, right? So as this is a binary string, the string contains only 0 and 1. So if the character is 0, then it's going to become 1 and vice versa. So the ask is, so we need to find the minimum number of type 2 operation so that we can make the string alternative. Let's look into constraint as well. So here you can see the length of the string can be 10 to the power 5. So if we are solving the problem even O of n square means the time complexity is going to 10 to the power 10, right? So it is going to give us 80 LE. So we need a better solution for this problem, maybe in the range of O of n or maybe n log n complexity. So let's take a look into an example. Here the binary string is 111000. So this binary string is not alternating. So what we can do to make it alternating is like we can do first type 1 operation, means we can move first to 1 to the end of the string like this. After that, what we can do is then we can flip the second and sixth element to make the string alternative. So during this process, we have made like 4 operations. Initially, we did like 2 type 1 operation, then 2 type 2 operation. So answer is going to be 2 because we have done only 2 type 2 operation here. So let's understand how to solve this problem. Let's take the same binary string here. So for this string, there is only two possibility how we can build the alternative binary string. Either the alternative binary string 1 or either alternative binary string 2. So for any given length, so we always going to have only two ways how we can build the binary string. So let's forget about the type 1, type 2 operation. So for any binary string, if let's say we have to make the binary string to an alternative binary string, right? So how we can how many like characters we have to flip? So how we can calculate that? To calculate the number of flip, we basically compare the given binary string with the possible alternative binary string. So here we have two alternating a possible alternative binary string. So we are going to compare the given binary string with them. So here you can say for the first with the first alternative string we have to do two flip. So the first index and our fourth index, and with the second alternative string we have to do four flip. So the minimum number of flip is going to be 2 here. So if you look closely, right, so this is nothing but our operation 2, where we can choose any character from the string and we can flip the bit, right? So this is, you can say, the type 2 operation here. Let's understand type 1 operation. So in the type 1 operation, what we can do is like we can pick the first character and append in the end of the string, right? So basically what we are doing is like this, right? So we are picking up the first one and then we are adding at the end of the string, right? Accordingly, like we can do to the second character as well, third character as well, fourth character as well, so on and so forth, right? So what you can see here is we are moving in a cyclic manner. Basically, the type 1 operation, what it's doing is like it is generating new strings which we can get if we move along the string in a cyclic manner. If let's say this string is given, right, after doing all the type 1 operation, we'll be getting this string if we're like moving in circular manner, but we don't have to do the last step because right now if you see, right, the yellow portion and the gray portion are the same, right? So means uh, we are taking up the same thing what initially is given, right? So we don't have to do the last step. So right now it's kind of like you can say a sliding window problem, right? So what we have to do is like we have to take a window of length 6 because initial string length is 6. So let's take it like window length of 6, and we have to slide the window, and we have to check how many bits we have to flip so that we can make it alternating, right? So in high level, that's the thing we are going to solve in this problem. So let's take a look into the brute force approach here. So we'll be given the string as here. The length of the string is 6, and for this possible alternating binary string is this one alternating S1 and S2, right? So as we see that in the type 1 operation, we are moving in a circular manner. Because of that, we are going to get this final string. So now we have to like slide the windows. Basically, we are going to move the alt S1 and alt S2 along this final string and see like how many flips we have to do for each and every iteration. So this is the brute force approach. So in this brute force approach, we basically get the final string and we are sliding uh, the possible alternative binary string along with it and calculate the flip we have to do, right? The time complexity is O of n square for this, and space complexity is O of 2n plus O of n plus O of n. Why 2n? Because of the final string, and O of n, both the O and n is for this alternating string. So uh, this solution can solve this problem, but it will give you TLE. In brute force approach, what we're doing here is whenever we're sliding the window, right? So basically what we're doing here is we are removing an index and we are adding a new index, right? So let's say initially we started from the window 0 to 5, but in the second iteration what we have to do is like now we are interested in 1 to 6. So basically we are removing index 0 and we are adding index 6, right? If somehow we can calculate what is the contribution of the index 0, right? And we can remove the contribution from the previous value, and somehow like we can calculate what is the contribution of index 6, and we can add that contribution to the our answer, right? And in this way like we can like progress, right? So for that, what we have to do here is like instead of like taking alternating binary string of length uh, of the like original string, we can take the alternating binary string of length of your final string, right? Then it's going to be easy. What was the contribution of the remove index and what is the contribution of the newly added index, right? So right now, if you see in the example, right? So if we like go into the next iteration, right? So what we have doing is like we are removing the index 1, right? Index 0, sorry. So for that index, so if you look into the alternative string 1, right? So index, both the index zeros are matching. So there was no contribution for it, right? But for the alternative string 2, so the character are not matching. So the there's a contribution of right? So for the string to answer, so first thing is like we have to remove that contribution and we have to add the new contribution from the length 6. So that's how we are going to progress. So for this one, the time complexity of this solution is O of 2n, space complexity of O of 2n plus O of 2n plus O of 2n. Why? Because we are using like all the alt string and the final string of length 2n, right? So here space complexity is a little bit more. That also we can optimize in the next approach. So if you look closely to the alternative string, right, you don't have to create the whole alternative string, right? So if you observe it, so alternative string one started with one, then it's zero, then one and zero, right? So you can say that the bits are alternating here, right? So if let's say you have an index I, right? At that index you have the bit as one. So in the index I plus one, the bit is going to be zero, right? So what you can do here is like you start with a bit, and it for each and every iteration, you can like invert that bit and use it, right? And accordingly, you can do the same thing from string 2 as well. Let's take a look into the final string as well. So initially we are interested in 0 to 5, right? In the next iteration, we are interested in 1 to 6, right? So if you look into that indices closely, in the 0 index we have 1, and in the 6th index we have 1, right? So both the character are same, right? And accordingly, if you look into the in the next iteration, we are interested now in from 2 to 7, right? Again, like what we have in the index 1 is 1, again in the 7 is 1, right? So what I can say is whatever character we are removing, right, the same character we are adding as well, right? So uh, you can say that you don't have to create that you don't have to create the complete final string, right? Instead of that, what you can say is like uh, initially just calculate the values for each and every alternative string, right? After that, again start from index 0, right? So in the next n minus 1 iteration, what you're going to do is like you're going to remove uh, the same index value, and going to add the same index value in the end of the string, right? So that's what you're going to do. But there's a question, right? How you're going to calculate whether that remove index value is contributing or not, right? For that, let's understand the flow of this solution. So here we are going to initially we are going to start with a bit, right? Let's say the start bit is 1. We're going to take a reference to the bit as well, right? In the first iteration, what we're going to do is like we're going to inverting that bit, and we are going to compare with the string values, right? So here the start bit is like 1. So 1 we're comparing with 1, so that is 0, right? The next bit is going to be inverted of the start bit, so that is 0. So again, like we're compare with the index 1. So accordingly, we are going to calculate the next bits, and we're going to compare with the corresponding bit from the string, right? In the second iteration, what we're going to do is like we're going to remove the value at index 0, right? And we're going to add the same value to the end of the string, right? So right now what we're going to do is like as we are removing, right? So we have to check like initially at index 0 whether it's contributing or not, right? So for that, like we have the reference bit, right? So the reference bit is equal to 1. So we are going to compare the 1 with the reference bit, and we are going to deduct that value. And also like as we are adding 1, right? So we are going to first calculate the next bit, which is going to be 1 in this case, and we are compared with 1, right? So in the third iteration, what we're going to do is like we're going to remove the value from index 1, right, which is 1 again, and we're going to add 1 again like end of the string. So the how we're going to see whether that index 1 was contributing anything to that value or not. So that is going to be decided by the next of the reference bit. So the next of the reference bit is going to be 0 because previously it was 1. And with the next bit, which is like 0 because next bit was 1 there. So in this way, we're going to solve this problem. For the solution, the time complexity is O of 2n, and the space complexity of O of 1 because we are not taking any extra spaces here. So let's jump into the code. This is the Java implementation of the optimized solution. If you look into the solution, so there you can see I have a start bit and reference bit. So after that I have a for loop. In that for loop I have completed my first iteration. So after that I have another for loop. There I'm removing a character and adding a new character to that. The removing character contribution I have like calculate using the reference bit, and the newly added bit contribution I'm calculate using start bit. So that's how I'm implemented the solution. So that's all for today. See you in the next video. Thank you.